Welcome, this is the lesson on scientific notation. So how do we do scientific notation? Scientific notation is just a shorthand way of writing numbers. So as you've seen before, we have numbers that look ridiculously small, or ridiculously big. We don't want to write all of these zeros all the time, especially in biology, where the number of an atom or a molecule can be extremely small, or we can go into the number of population, which can be extremely big. So, how do we simplify these numbers? These are just base 10. That's what decimals mean. Deci means 10, so decimal means it's just the decimal or the point is base 10. So, for example, we can move the decimal to the right to make this number a real number. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we stop here. 6.5 times 10 to the negative 10. As you see here, this number has two components. 6.5, which is between 1 and 10, and 10 to the negative 10, which is indicating how many spaces you moved. In this case, we moved 10 spaces, and because this number has become bigger, right, 0.00065 has become 6.5. This is a tiny number become a big number. This number becomes a small number, so 10 to the negative 10. Every time you move the decimal in the direction that makes this number bigger, the exponent is negative. I'm trying really hard to avoid saying I move the decimal to the right or to the left, because a lot of students get really confused about left and right eventually. So if you're the kind of person who does not get confused between left and right, if you move the decimal to the right, then your exponents has to be negative. Negative exponents. So let's look at this number. We have the decimal all the way out here. Now let's move to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I stop here. We would have 6.95. I forgot how many I counted, so I'm going to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 10 to the 14th power. Again, if we move the decimal to the left, then the exponent is positive. One way to think about this, without thinking about how the right and the left might be confused, is to say that if the main number becomes smaller, the exponent is big. And if the main number becomes big, the exponent is small. And by saying big, we mean positive. By saying small, we mean negative exponent. Let's try another example. If we have a number, say 0.00000000459, we can move the decimal to here where it's 4.59 to make sure that this number that we have is between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4.59 times 10 to the negative 10 power. Again, because we move the decimal in the direction that makes this number bigger, therefore our exponent has to be smaller. Or we can do 465 we have to move the decimal from here to here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 4.65 times 10 to 11. So now, let's look at all the problems together in the next video.